Hello everyone, welcome to today's video. In the last lecture we have already completed the chapter Hello Alkanes and Hello Arenes. In today's lecture we are going to discuss the topic amines. This is going to be the second last chapter if you go sequentially in the book, but we are picking up amines first. Okay, so let us start. The chapter is a short chapter and a lot of things are not there, and some things you already have learned in the previous chapters. Okay, so let us begin with amines. The first topic that we are going to start in amines is regarding amines. What is an amine? Then we'll move on to isocyanide and cyanide. That is the last part of the chapter. So amines. So what is actually an amine? Amines actually are derivative of ammonia. So that means you have NH3. So moment you start replacing the hydrogens with an alkyl group, then it becomes a amine. So in organic chemistry, amines are ammonia derivatives. So they will be acting as a base. Clear? That means RNH2 will be accepting a proton to form RNH3 plus. This is what you all know already. Okay, then see, the first time when we replace the hydrogens, we got RNH2. This is called 1 degree amine. Okay, and I will discuss after some time. Moment we replace one more hydrogen, we get RNHR. This is called 2 degree amine. It's called secondary amine. Alright. Moment we replace another one, we got RNR. This is called tertiary amine. Tertiary amine. Okay, that is called 3 degree amine. That means no hydrogen is available. This is how we will differentiate between amines. Later on I will teach you the Hinsberg test will differentiate. See here, next step, if we introduce another R, then this nitrogen has a lone pair. That lone pair will be coordinated to form a quaternary ammonium salt. You can see the overall there is a positive charge. If I want to show it to you properly, then I can show it like this. Just give me 1 minute. See, can I write like this? An overall positive charge. So if there is overall positive charge, some ionic part will come and attach to it, and this is called quaternary ammonium salt. Quaternary ammonium salt. Why quaternary? Because you can see 4 alkyl groups are there. Ammonia, because it is a derivative of ammonia. Okay. Now this is not a very important thing, but you just know that in case of 1 degree amine, the nitrogen is a pyramidal shape and it is going to be sp3 hybridized. Since it is having a lone pair, definitely it is not going to be tetrahedral shape, it is going to be pyramidal shape. Alright, it is going to be sp3 hybridized. Alright, aromatic amines means the amine group is attached to the aromatic ring, that is benzene ring. This is the most commonly we use aniline. NH2 on top of benzene ring. Done. Next, classification of amines. This is completely theory based. Nothing to use your brain about. Okay. So I've already written it down before. Okay. Classification of amines. Basis, number of hydrogen atoms attached to nitrogen. So how many hydrogen attached is attached to nitrogen? On the basis of that, we have classified amines into 3 types. That I have already shown you here. 1 degree amine, 2 degree amine, 3 degree amine. Right? If there are 2 hydrogen attached to nitrogen atom, it is 1 degree amine. If there is only 1 hydrogen, it is 2 degree amine. If there is no hydrogen, that is a 3 degree amine. Okay? So that is only written RNH2, 2 H atom attached to nitrogen. Example, methylamine. 2 degree amine, also called secondary amine. RNHR, 1 hydrogen atom will be attached to nitrogen. Example, you can see 1, 1 dimethylamine. Okay? And if there is no hydrogen attached to the nitrogen atom, this I should write no hydrogen present on N atom. Okay, so no hydrogen present on N atom, then it is a 3 degree amine. Example, you can see there are 2 lone pairs. Sorry, 1 lone pair on nitrogen. Okay, 1, 1, 1 trimethyl amine. So this part is very easy, completely theoretical based. I hope there is no doubt till now. Next, quaternary ammonium compound. This I think I have already told you before. Now based on the nature of groups that is attached to nitrogen, what groups are attached to nitrogen, that is also going to matter, right? If there is hydrogen attached, then we have done the classification. But if there is not hydrogen but something else that is attached to nitrogen, then in that case what it will be? So based on the nature of the groups attached to nitrogen, we have divided into two types, aliphatic amine and aromatic amine. Okay, aliphatic means open chain compound, that you already know. So alkyl groups will be directly attached to nitrogen, then that will be open chain compound. So those are going to be aliphatic amine. Moment it comes aromatic amine, it can be aryl amine or it can be an alkyl amine or aryl alkyl amine. This is a very important one. In alcohol phenol ether also will find alcohol also, not ether actually. Alcohol you also will find the same thing. Aryl alcohol and alkyl alcohol. That means aryl amine means the amine group will be directly attached to the benzene ring, and if it is alkyl amine, that means the amine group will be attached to the side chain of the aromatic ring. Did you understand? I will be explaining you. Aryl amine, amine group directly attached to the benzene ring. If it is alkyl amine, then the amine group will be attached to the side chain of the benzene ring. Okay, let us understand. See here. Aryl amine, aryl group attached to N atom directly. So that is aniline, and this is triphenylamine. You can see all the three phenyl groups are attached to nitrogen. So nitrogen directly attached to aryl group. Right? That is a benzene ring. So this is a aryl amine. Alkyl amine, you see, the nitrogen is attached to a side chain of the benzene ring. You can see benzene ring এর সাথে একটা CH2 আছে, তার সাথে NH2. So it is not directly attached to the benzene ring, but it is attached to the carbon next to the benzene ring. So this type of things are called alkylamine, and this, remember, alkylamines are always more basic than aniline, that is than arylamines. Why? Because there is a plus I effect group CH2, actually CH3, but that is a plus I effect. Okay, so if N is attached, the nitrogen is attached to the side chain of aromatic ring, then we will be calling it as alkylamine, and if it is directly attached, then it is directly aryl amine. Clear or not clear? Clear? Very good. Next. This is, you can see just two names have been written. This you can do it for your IUPAC. Nothing to explain, just check it out. Alright, next. Preparation of amines. Now we are coming to the reaction part. Preparation of amines. First is the preparation from alcohol, and let me write it in the bracket. The reactions are already been written. It is industrial method of preparation. Industrial method. Okay, so if in the question it is coming, write the industrial preparation method of amine, then actually it is asking you for preparation from alcohol. Alright. So you can see that I have taken one alcohol ROH and I am reacting it with NH3, ammonia, not amine, because I have to form the amine. I cannot react it with amine, I have to form the amine. So alcohol, when reacted with ammonia, you can see in presence of a dehydrating agent. If you remember class 10, alumina, this is called alumina. Alumina is the only solid dehydrating agent. You have discussed it in class 10. So you should not forget that this is a dehydrating agent. Dehydrating agent. So the work of the dehydrating agent is to take out water from the reactants. So how the water is going? This way it is going. From alcohol OH is going and from ammonia H is going. So ultimately the remaining parts are joining. That's RNH2 formed. So you have to remember two things, that is the temperature 633 Kelvin, ROH reacts with the ammonia to form a primary amine. This is a 1 degree amine, right? Now if you want to form a 2 degree amine, then you have to take a 2 degree, sorry, if you are forming a 2 degree amine, then you have to take a primary amine. So if you are taking a primary amine, you see it's a primary amine, you have taken that and have reacted with alcohol again. Then you are getting a secondary ammonia, secondary amine, sorry, not ammonia. And when you are taking this secondary ammonia, secondary amine, and you are reacting it with alcohol again, you are getting the 3 degree ammonia. Clear? Clear? You can see it is coming ammonia from my mouth, but it's actually amine, huh? Please make it. Because I am more used to say ammonia than amines. We will say amines. Okay, anyways, fine. So ROH plus NH2H, that is 1 degree amine. then it will be forming a 1 degree amine, right? So first reaction is with alcohol ammonia, then 1 degree amine. If that 1 degree amine further reacts with alcohol, it will form 2 degree amine. If the 2 degree amine further reacts with alcohol, it will form 3 degree amine. Clear or not clear? It's very simple. You have to remember the reagent, that is Al2O3 alumina at 633 Kelvin. Alright, done. Next, if there is a 3 degree amine and you are trying to further react it with alcohol in presence of Al2O3, then reaction will not happen because there is nothing what? No hydrogen is present. So if you are further reacting this with alcohol, then you will not get any product. Why? Because there is no hydrogen plus ROH. Then you will not get any product because there is no hydrogen, and how the water will be eliminated. Clear? So this is the thing that you need to remember from here. Done. I hope this is clear. From alcohol, how will you prepare amines? Done. Next, second one is called Hoffman ammonolysis. Hoffman ammonolysis says that this is actually the preparation of amines from alkyl halides. From alkyl halide. So if the question comes, method, write a reaction, or how will you prepare amine from alkyl halide, then this reaction needs to be used. Hoffman ammonolysis. Okay. So Hoffman ammonolysis is basically you are taking an alkyl halide. Last time you took an alcohol and you reacted it with ammonia, which gave you a primary amine. Here also will take ammonia, but you will not take alcohol. You will take alkyl halide. Alright. So as you can see, if you have taken the alkyl halide, then alkyl halide's R1 is getting a del plus because X is more electronegative. So it will be taking away the electron from it. So R gets a plus del charge. So the nitrogen's lone pair will be donated to R, right? Donated to R. So moment it donated, X minus is out, and NH3 has 3 hydrogen, 1 hydrogen thrown out. So ultimately it forms HX, and that gets out, and RNH2 remains. Clear? Now, if the reagent is in excess, then the reaction will not stop at RNH2. Obviously, you can understand that it will not stop because in presence of NH3, RNH2 will again react to form 2 degree amine, then 3 degree amine, then ultimately a quaternary ammonium salt. Right? So you can see the reaction continues. So the thing that you have to remember is, if you have been given with an alkyl halide and you have to prepare 1 degree amine or 2 degree amine, whatever the question is given, then you are going to use Hoffman ammonolysis. Is it clear to you? I don't think it is a hi-fi concept, nothing like that. It's easy. Alright. So you have to take Rx and you have to react it with ammonia. What will happen? I have told you. Mechanism is this much only. Otherwise I would have told you. Alright. Hoffman ammonolysis is clear to you? Clear? Alright. Now you can see that this X is getting eliminated. Right? So the ease of leaving X will be the reactivity of the compound. So can you make a note? Just note it, though you already know, nothing new I am telling. Note reactivity order will be HI greater than, sorry, not HI, sorry, RI greater than RBR greater than RCl. I think I did not explain why it is so. It is simply because the leaving group is leaving. The better the leaving group, it will be the better, right? The better the leaving group, the better it is. Acha, Hoffman ammonolysis is clear, right? Next, cyanides. This will be a very important, very important conversion. Why? Because in most of the case you will find conversion will be given ascending the number of carbons. Like suppose methyl alcohol to ethyl alcohol. How will you make that conversion? For that we will use this intermediate step. But this step is very important because when you are converting from methyl alcohol to ethyl alcohol, ultimately you have to come to cyanide, because otherwise carbon number will not increase. Okay. So if you have to prepare from cyanide and amine, then you will be simply reducing it. Very important, you will be reducing it. So RC triple bond N, if it is reduced in presence of LiAlH4 or sodium amalgam as alcohol, or zinc HCl, SnHCl, or nickel, whatever you use, don't use sodium borohydrate. That usually does not happen over here. Okay, so that will form a primary amine RCH2NH2. You can see the carbon number, whatever originally it was, you have increased. Or see, originally it has increased over here only. RCN bere geche. But I have to remove that bond. No, that is why I have come to amine. Clear? Alright, this is used in the ascent of number of carbon atom later on, not now. So RCN, when I am reducing it, I am getting amine. Simple. Nothing to worry about. It's easy. Next. Hofmann-Bromamide degradation reaction. Just now we have seen ascent of carbon atoms, right? That means from methyl alcohol to ethyl alcohol. Now if I have to come back, then what will I do? If I have to come back, then what will I do? Then I have to degrade the number of carbon. Though from alcohol to lower alcohol, if I can, will not degrade the carbon atom using this method, but still, whatever the question is based on that. So if we have to degrade the number of carbon, we will use Hofmann-Bromamide degradation reaction. Okay, where amide is there and it gets converted to an amine of lower carbon. Why? Because that CO group is not there. It will go out as Na2CO3. So that is not there. So one carbon will get lesser. So you can see it is there RCONH2. In the product it is RNH2. Just the CO group has gone out as Na2CO3. Not definitely not as CO2. Okay. So the reagent that you need to remember is bromine, sodium hydroxide. Instead of sodium hydroxide, same family member, you can use potassium hydroxide. But the reagent that has been used by Hofmann was bromine and sodium hydroxide, so you don't change it. Okay. So in presence of bromine and sodium hydroxide, RNH2 primary amine is formed along with water, sodium bromide and sodium bicarbonate. Okay. Sorry, sodium carbonate, not bicarbonate. Alright. So amide is there and 2 amide amine. This is Hofmann bromamide. The name is only telling you. See the name properly. Brom. This brom means bromine is there. Amide is amine is there. Amide is there, and degradation means decrease in number of carbon. So everything the name is only giving you. Okay. So amide plus bromine plus NaOH will give you one primary amine. Done. This is the khatarnak mechanism which you can say if you want to disturb your brain, you can see the mechanism. If you don't want to disturb the brain, no need to see, not required. See, I am explaining it. Listen. So you have RCONH2. That I have written as NHH. Any problem? No. OH minus, where it is coming from? NaOH. Alright. OH minus takes up this H. Ultimately water is there, leaving water left. So if this hydrogen is being taken away, that means N will get a minus charge. That is only here. Now Br bond was there, bromine taken. So this minus attacks one bromine. So ultimately what happens is NHBr will form. See, NHBr forms. Br is released as Br minus in the solution. Done. Now you see RCONBRH. So RCONHBr, OH minus was already in the solution. OH minus again takes up this hydrogen. So this step is getting repeated. Taken. So ultimately again I am getting N minus Br. Now you see no more hydrogen is there. So if no more hydrogen is there, then again the step will not repeat. Now what happens is N minus is there. The Br is leaving out and R is migrating, because if it is not migrating, then carbon will have 5 hands, which is not possible. So the R migrates to the nitrogen side. So I am getting R C double bond O, N double bond C and R on N hand, this one, right? Now oxygen's bond is broken. Oxygen takes a minus. So oxygen minus, that means hydrogen will come up on oxygen. Now you see this step properly. Rn double bond C O minus. See this step very carefully. OH minus. This minus attacks and comes over here, and this bond breaks. So I am having RCO minus and OH. This hydrogen comes over here in nitrogen side. So ultimately this side I am having double bond O now, and one O minus, this one already there, this step. So NH you can see This bond has broken already. Now this bond also breaks. So CO2 gets released and RNH2 is formed. I know the mechanism is a little bit difficult because of complications in the second last step and the last step. So if you have not understood it, it's not a big deal, but the reaction you have to know. Alright, next, reduction of nitro compounds. If I am reducing a nitro compound, I will get amine. Okay, in the end of the chapter we will find if it is nitrobenzene, then what will happen, that I will tell you in the end of the chapter, not now. So reduction of nitro compounds, RNO2, where R is an alkyl group, then I will get amine in presence of acid medium. Okay, SNHC you are using in acid medium, SNHCl or FeHCl or LiLH4, then you will get NH2. Okay, if it is not an acid medium, please remember in acid medium only will happen. Acid medium. At the end of the chapter, I will tell you what happens in base and neutral medium. In neutral medium, partial reduction will happen. That I will tell you later on, not now. So in acid medium, nitro will give you amine. Then reagents are given. Just learn the reagents, okay, not the reaction. Nitro, reduction, amine. Simple. Alright. So reduction of nitro compounds give 1 degree amine. Okay. Next one. Gabriel thalamide synthesis. Very important. This one is an important one. Okay. Gabriel thalamide synthesis. So from thalamide we will prepare amine. So let's see how. So we have one thalamide. How does the thalamide look like? Right. This is called a thalamide. So this one, when I will be treating it with alcoholic KOH, this hydrogen will get replaced by potassium ion. So that is acidic hydrogen, right? So let us keep it up. Okay. Now after this, if I am treating it with a Rx, then what will happen? K will take X and R will enter over here. Okay. So what will happen? N minus. Let's not write this minus over here. Okay. So this will give NR. Then last step, what will happen is, if I am giving here aqueous NaOH, then what will happen? This bond and this bond will break. So ultimately R and two hands free, NH2. Basically I will give you water, aqueous NaOH and water, na? So water's H will come here and oxygen and OH minus will go here. Okay. So this will form C double bond O H, and the byproduct that will be formed is RNH2. So this is basically Gabriel thalamide synthesis, where I am actually getting a 1 degree amine. Okay. This structure is called N-alkyl thalamide. This structure. Writing over here because below you cannot see. N-alkyl. Alright, this is N-alkyl thalamide. Whatever is the alkyl, accordingly we will write the name. This is Gabriel thalamide synthesis. Clear? Clear? Next. Why is there empty space? The reduction of amides. How does the amide look like? RCONH2. Done. So if I am reducing it by using a reducing agent LiLH4, then this group will be going out. So it will form RNH2. Okay, byproduct not required because this is not the SC syllabus. So no need to worry. Okay, RCONH2 will form RNH2, 1 degree amine. Okay, accordingly if you change this one, this will also change. So that I don't have to say. Next one, reduction of isocyanide. Isocyanide is basically Rn triple bond C. So if you reduce the isocyanide, then instead of 1 degree amine, you will get 2 degree amine. So you will get RNHR. Remember, very important, reduction of isocyanide gives 2 degree amine. So whenever you are reducing isocyanide, you will get a 2 degree amine, that you have to remember, because it will be required in your JEE back process. Okay, clear? Oximes, reduction of oximes, RCH double bond NOH. This is an oxime. If you reduce an oxime, you will get an amine. Okay, for oximes, the reducing agent we use is sodium amalgam in alcohol. Any other reducing agent is possible. So oximes when reduced gives amine, which is reduction of oxime. Simple. Okay, next one. Next we have alkylation of azide ion and reduction. Acha, 1 minute. What did I write? RNH. So sorry. It is not RNH2. It will be RCH2NH2. Okay, 1 degree only, but RC. Why? Because this C is there, no? That one is there. Okay. Alkylation of azide ion and reduction. First you have to see what is an azide ion. RX is an alkyl halide, done. But what is an azide ion? Azide ion is basically N double bond N double bond N. Between one is plus and both the side minus. This is azide ion. Okay. So when azide ion is reacting, this minus attacks this guy. This minus attacks this guy. So what will form? NR double bond N plus double bond N minus. Okay. Then when I am reducing it using LiAlH4, what happens is this bond will break. 2 hydrogen will come this side because 2, and this side nothing will go. Hydrogens will come this side. This bond will come over here. Alright. So what will form is RNH2 plus the nitrogen will be going out. Clear? This is alkylation of azide ion and its reduction. Doubt? Any doubt? I don't think there should be any doubt because it is very easy and clear. Nothing complicated. Easy? So we have completed the method of preparation of amines. Let me just summarize it. We have started from this one. From alcohol we have seen using alumina at 633 Kelvin we can prepare 1 degree, 2 degree, 3 degree amine depending on what the reactant is. Secondly, we have seen Hofmann ammonolysis. If we are using excess ammonia, then ultimately we are getting a quaternary salt. Cyanide, if you reduce a cyanide, you will get a amine, 1 degree amine. Hofmann bromamide, from amide, if you have to go to an amine, then you will use Hofmann bromamide degradation, where the reagent is Br2NaOH. Mechanism is shown, not required. Reduction of nitro compounds. If you have to go from nitro to amine, then you have to reduce it. If it is aliphatic, no problem. If it is aromatic, then in acid medium only. otherwise it will give some else product. Okay. Gabriel thalybate synthesis, we have just discussed that we will prepare a thalybite alcoholic KOH, then we will get N minus K plus, then Rx, then the K will take the X and R will replace the K, so NR is formed, it is N-alkyl thalamide, then we will use aqueous KOH hydrolysis, it is actually OH minus hydrolysis, then we will get, that is basic hydrolysis rather, so we will get RNH2 and phthalic acid, okay, this is phthalic acid. Phthalic acid. Okay. Next one. Reduction of amine. Amine, if you use a reducing agent, you will get amine. Isocyanide. Reduction of isocyanide gives 2 degree amine, not 1 degree amine. Cyanide gives 1 degree amine. Isocyanide gives 2 degree amine. Okay. Oximes. If you reduce the oxime, you will get RCH2NH2. Okay. Azide, if you reduce, you will get RNH2 and the nitrogen gas that was there will be thrown out. Alright, clear with the method of preparation of amines? Next, we are moving on to the alkylation of azide. Alkylation of azide. Alkylation of azide, I will repeat again because this is an important one and this is something new. Azide is N double bond N double bond N. Okay, middle one is plus and sided যেগুলো আছে that those are minus. If you do not even remember the structure, remember it as N double bond N double bond N, মাঝখানেরটা plus remaining to minus. Okay, যে কোনো একটা minus কে you react it with R, you attack R, not react, sorry, attack R, then the R will attach to that one, attached, then in between you break one double bond, then two hands will be open, both the hands give hydrogen, so RNH2 and the N2 that was there will go out. Clear? Done. Next we are moving on to the physical properties of aliphatic amines. Physical property. We have to study about the state, solubility. Okay. So let's start. State. The lower amines are colorless gas at room temperature while the higher amines are colorless liquids at room temperature. These I have already written to save time. I have already written it before. Okay. So if I am talking about the lower amines, then they are colorless gases, and the higher amines are colorless liquids. Understood? So if it is a lower amine, it will be gas. If it is a higher amine, it will be a liquid. Aromatic amines, if I go, then they are always colorless liquids. Not always, usually colorless liquids. And turn brown upon oxidation. This one is important. And they turn brown upon oxidation. That means if you oxidize them, it will be brown in color. Clear? So state, lower amines, colorless gas, higher amines, colorless liquid, aromatic amine, mostly colorless liquids. Alright? Next. Solubility. Solubility of a substance is actually depending on the hydrogen bond formation. You have seen that for all the compounds in chemical bonding in class 11, you have seen that hydrogen bonding, how it is happening. Right? There was a question, HF is soluble in water but HCl is not. Why? Because HF can form strong hydrogen bond, HCl cannot. Right? So this type of questions are there. So actually solubility of a substance is proportional to hydrogen bond formation. If it is going to form hydrogen bond with the solvent, then it is soluble, otherwise not. Okay, so all the three amines can form hydrogen bond with water, be it 1 degree, 2 degree or 3 degree, all are forming hydrogen bond with water. But if I talk about the solubility order, then it is 1 degree greater than 2 degree greater than 3 degree. Why? The reason is solubility will always decrease with increase in the hydrophobic part, that is the alkyl group. If the alkyl groups are increasing, then the hydrophobic nature is increasing. Alkyl parts, they don't like water, they want to go away from the water. Okay, so more and more the alkyl groups, if you try to increase it, then automatically the solubility will decrease. Okay, that is why 1 degree, when there is least number of hours. In 2 degree there are 2 hours, 1 degree only 1 hour, and 3 degree there are 3 hours. That is the reason. Alright, aromatic amines are sparingly soluble because they will not form very strong hydrogen bond. Then boiling point. Amines have a higher boiling point than hydrocarbons of comparable masses but lower boiling point than alcohols or carboxylic acid. Why? What did I say? Amines will have higher boiling point than the hydrocarbons of comparable mass, but the boiling point of amines will be less than the alcohols or carboxylic acid of comparable mass. Why? In alcohol, the hydrogen bonding happens from the O center, and here it is happening from the N center. Who is more electronegative? O. So the hydrogen bond formed by alcohols will be more stable or more stronger than this. That is the reason. Alright. See, it's written electronegativity of oxygen is more than nitrogen, so the hydrogen bond formed by alcohols or carboxylic acids are stronger than amines. So order of boiling point will be obviously 1 degree greater than 2 degree greater than 3 degree. Reason? 1 degree te 2 NH bonds are there. In 2 degree 1 NH bond is there, and in 3 degree no NH bond there. Clear? Right? In 3 degree to all NR. Then who will form the hydrogen bond? No hydrogen bond formation only. Alright, intermolecular. See, boiling point is increased by intermolecular hydrogen bonding. So it has to form intermolecular hydrogen bonding. If there are no hydrogens only in 3 degree, no hydrogen is there, then how can they form intermolecular hydrogen bonding? Then no question of order of BP increase. Clear? Any doubt? I don't think there should be any doubt because this is not a difficult part. Okay. Then next, chemical properties of amines. Under chemical properties of amine, the first thing that we will read is basic character of amine. You know what is a basic character? Ability to donate electrons. In organic chemistry, it is the ability to donate electrons. In inorganic, it will be different. But I am talking about organic right now. So basic character means the ability to donate electron. Nitrogen has a lone pair, so it will be able to donate electrons. So it is showing a basic character. Now, in class 11 in GOC, you have learned basic strength is proportional to electron donating groups, right? That is plus I effect. So electron donating groups will show which effect? They will show plus I effect, right? And stability of conjugate acid. What is conjugate acid? Conjugate acid is basically base plus H plus, right? Protonated base is conjugate acid. So if that is stable, then it will be increasing the basic strength. Alright. So basic strength proportional to electron donating group or plus I effect and proportional to stability of conjugate acid. Conjugate acid is basically base plus a proton. Alright. Now you see here I have written one important thing. Very important. Basic strength increases, Kb will increase. What is Kb? I am telling. pKb will decrease. Now what is Kb? What is pKb? Class 11th. Class 11th. Ionic equilibrium. There was a chapter. In ionic equilibrium, you have learned these two terms. Kb, pKb, Ka, pKa. What is Kb? Kb is ionization constant. Ionization constant for weak base. And if I talk about pKb, then pKb is nothing but minus of log Kb. Okay, now you see, as you increase the Kb value, the pKb value will decrease because a minus sign is there. अरे बाबा Kb value बढ़ले तो minus है तो pKb value कम ही जावे. That is what I am saying. As and when the Kb value will increase, the pKb value will start decreasing. So if the question is asking arrange in the increasing order of pKb or arrange in the increasing order of Kb, you have to first see what the question is asking, because pKb and Kb are ulto, but basic strength and Kb are same. So if they are asking to arrange in the order of PKB, then ultimately arranging in the order of basic order, then reversing it. So you have to know that you have to reverse it, because in one of the options it will be the basic strength order and another option will be the opposite order. So that will be the confusion point. So you need to be very clear that if basic strength increases, KB will increase, but PKB will decrease. Reason is here, PKB is equal to minus log KB. Alright, this is class 11 ion equilibria. There you have learned all this. Okay, ionization constant for weak base. Understood? Done? Okay, now next. I have given you two set of questions for you to attempt. Please pause the video and try to attempt the questions, because from basic character the questions they will ask you is in this way, is in this format, or they can directly give you certain open chain compound. I'll talk about open chain compound, but before this attempt these two questions. I hope you have attempted the two questions. Answers to these questions I will give you, not right now, after some time. First let me discuss something else. Then just after some time I will give you the answer to this question. Now you see. This was for aromatic one side. Coming to aliphatic amines. See, 1 degree, 2 degree or 3 degree aliphatic amines, gaseous state. So they are in what state? They are in gaseous state. Now, if they are in gaseous state, so the compounds will be R, NH2 like this, R, NH, R, and the other one will be R, N, R. Now you tell me, just now I told you, basic character is depending on electron donating groups. So how many electron donating groups? One electron donating group. How many electron donating group? Two donating group. How many donating group? Three donating groups. So who will have more basic character? Lone pair. Obviously this all. So is it clear? Easy? Right. Order is clear. Why the order is so? I have told you. Let me write it over here. One alkyl group. One alkyl group. Two alkyl group. Three alkyl group. Right? Clear? So in gaseous state, the order is 3 degree greater than 2 degree greater than 1 degree. Clear? Please do not forget it. You will have to remember this. Okay. Now, after gaseous state, we move on to the aqueous state. Now, problem that is coming up in aqueous state, let me tell you. See here. In aqueous state, water will be there. And as I have already told you, in solubility, that amines with water will form hydrogen bonding. So that will be a problem, right? And secondly, the problem will be this alkyl groups. So what will be the order of this basicity in aqueous solution? That is a question mark. Hence, I have to consider two factors. What are the two factors? Listen. First factor is factor 1, that is the electronic factor. Electronic factor. See, I cannot ignore electronic factor. Why? Because base definition is only that basic strength will depend on number of alkyl groups of plus I effect. So I cannot ignore that. So this one I cannot ignore. So if I am following the electronic factor, then what am I getting as my answer is 3 degree greater than 2 degree greater than 1 degree. Do you have any doubt related to this? I don't think, because just now I explained you why it is so. Now, if I am considering the second factor, which I have to consider because it is an aqueous state, that is factor number 2, that is called hydration factor. that is called hydration factor. What is why did we consider hydration factor? আমার তো কোনো দরকার ছিল না. Why? Because in aqueous state, water is an external element. Sorry, compound. Sorry. External molecule. And interaction between the external molecule and the amine is happening. That we already come to know before. That amines form hydrogen bond with water. So that will have some effect on the basic character. And what that effect will be, that I have to know. Okay, now you tell me what is the order of solubility of amines in water. That is the hydrogen bond formation order also. That is 1 degree, greater than 2 degree, greater than 3 degree. Already discussed before. So the order will be 1 degree, greater than 2 degree, greater than 3 degree. Order has been already discussed. Why it is so? I am showing it to you so that you don't have any confusion left. Solubility. See here. All three amines can form hydrogen bond with water. Solubility order is 1 degree, 2 degree, 3 degree. Reason: solubility of amine decreases with increase in hydrophobic alkyl part. Or you can also say that number of hydrogen is more. Whatever. So as and when the alkyl groups will increase, solubility will decrease. Right? So 1 degree has least number of alkyl groups. 2 degree has more number of alkyl groups. 3 degree has 3 alkyl groups. No hydrogen only. Understood? So this is the reason why it is going to form the hydrogen bonding in water. So now we are coming back here. So if we consider the hydration factor, then 1 degree will form the maximum number of hydrogen bonds, 2 degree will form a little lesser number of hydrogen bonds, 3 degree will form no hydrogen bond, very minimal. Will not actually. Now you see, if I have to come to a conclusion that what is the order in aqueous state, I cannot come to a conclusion. Why? See, electronic factor is giving me some order, hydration factor is giving me ulta order. That means both the orders are opposite to each other. So if both the orders are opposite each other, then I cannot come to a conclusion like that. Someone will say first one, someone will say second one. So what did we do? We did experiment. We researched on it, and after experiment and research, it has been found that in aqueous state, the order follows is, there is right the next page only. After research and experiment, order in aqueous state has been concluded as 2 degree, greater than 1 degree, greater than 3 degree. This is the concluded statement. Very, very important. Very, very important. 2 degree, greater than 1 degree, greater than 3 degree. Do not ask me the reason because I won't be able to explain, because it's a research and experiment which I cannot explain. Okay? Order in aqueous state after researching, because these two were controversial to each other. So after research and experiment, we came to the conclusion that secondary is more than primary than tertiary. Clear? What you are going to remember is this one: 2 degree greater than 1 degree greater than 3 degree. Alright, so let me just repeat everything. If it is in gaseous state, then we will simply check who has more number of alkyl groups based on the order is coming. 3 degree, then 2 degree, then 1 degree. If it is aqueous state, then the problem is with the factor number 2, that is hydration factor, that was not there. Hydrogen bond formation is happening, so order is 1 degree, 2 degree, 3 degree. But if we go by the electronic factor, then order is 3 degree, 2 degree, 1 degree. So both the orders are reversed to each other. That is the reason we could not come to any conclusion. Ultimately, after research and experiments, we came to the conclusion that the order is 2 degree, 1 degree, 3 degree. You need to remember this. Is it clear to everyone? Clear to everyone? Okay. Now let us come to the questions that I told you. So let us discuss these questions. This one you can see 3 compounds have been given and they have been told to compare the basic order. Okay, let me just copy this slide once. Edit the slide. Okay, can I remove all this? Now you see, maximum answers I will tell you. Okay, let me write the answers first. What answer you all will give? Answer. Uh, Alkyl group located close. A. Maximum. B. Further distance increase. C to less. So this one is the option number. Answer number 1. Answer 1. Why? See, I'm telling the logic also. What mistakes you will do? You will say inductive effect. Fine. Then distance is less, distance is more, distance is further more. So A will be first, B will be second, C will be third. Okay. Another student is using his brain. Another student uses his brain. Says hyperconjugation. Says para hydrogen is more labile. So C will be more. Then he says B. Then he says A. Okay. But to your surprise, this answer is also wrong. This answer is also wrong. What is the correct answer then? The correct answer is C, B, sorry. The correct answer is C, B, A. I think this one was correct. Why did I get it out? I have gone mad. Okay. The correct answer is C, B, A. Let me just remove this. So correct answer is CBA. Why is the correct answer CBA? Now, in class 11, you have learned about one effect called, or maybe you have not, but actually I think it was there in the GOC. That is called SIP effect, SIP effect, SIP, steric inhibition of protonation, SIP effect. I am writing here SIP, steric inhibition of protonation. This is called ortho effect. This is called ortho effect. So whenever you find such a condition where where ortho position is sterically hindered by a large alkyl group, do not directly jump into conclusion. First think, because steric inhibition of protonation, SIP effect will apply over there. So you can see over here that NH2 nearby there is a CH3. So there will be SIP effect applying, and due to SIP effect the protonation will not happen at NH2 easily. That is why A will not be the greatest, but A will be the least, C will be the greatest. Okay, clear? Because C is more labile also, that is also the reason, but actually C will be more than B than A. That so SIP, steric inhibition of protonation, ortho effect, that is taking place due to steric factors. Steric factors. Remember, whenever at ortho position there is an alkyl group attached, basic character will not be easily shown due to the steric hindrance by CH3. Okay, next question. Next question was second one. Here is the first one. Yeah. CH3 सीटा गायब हो गया. Okay, now let's discuss this one. Errors. Let's take some answers. Answer number 1. Answer number 1. Here the minus MFA group is there. Okay, here there is a plus IFA group and there are 2 plus IFA groups. So sir, S will be more. Then there will be R. Then there will be P. Then there will be Q. First answer. Very good. Second answer. P will be maximum. Followed by S. Followed by R. Followed by Q. Third answer. Directly giving through the ring, mesomeric effect, R maximum. P is having nothing, P. Then they are saying S, and at the end they are saying Q. 3 answers. Correct answer. Correct answer is this one. These 2 are wrong. Correct answer is S, R, P, Q. Now let us understand why. I hope this one you can understand that basic character is dependent on plus I effect, not minus I effect. So this guy is showing minus M effect. That is not needed. Okay. Here aniline has nothing else to do. Fine, very good. Here aniline is getting extra plus H. So it is very happy. So this will be automatically more basic than P. That much you can understand. Okay. Now the problem is with S. S, nitrogen directly attached to two CH3s. Now what is the concept coming in? See. If I draw ammonia, then ammonia is also having two lone pair, two lone pair electrons. There is one lone pair. Is it a very good base? That means if I am going to form a anilinium ion, NH3 plus, is it very stable? No. Why? Why? Reason is the electrons that you are thinking is being given, these electrons are delocalized. What is meant by delocalized? So these electrons are unavailable to be donated. Why? Delocalized means involved in resonance. Now in class 11, 1001 times you all have done the resonance structure of aniline. So I will not show the resonance structure of aniline. If you want to do, you can do it in your home. If you do, you will find that the electrons, lone pair electrons of nitrogen will be involved in resonance. If they are involved in resonance, they will not be available for donation to the external agent. That is why aniline is not a good base. That is, anilinium ion is not very stable. Did you understand this? Now, if this nitrogen, this one, this nitrogen you can see has two CH3 groups attached to it, right? This two CH3 groups again is causing a steric hindrance to nitrogen to donate these two, to give these two electrons to resonance. Due to the presence of these two alkyl groups, the nitrogen's lone pair is not involved in resonance, and this is having a name, special name called SIR effect, SIR effect. If you want to say C, that's your choice. I say SIR, I say sometimes SIR. So I am writing it over here. That's SIR effect. Steric inhibition of resonance. Steric inhibition of resonance. That means you can see that the electrons are not involved in lone pair in resonance. These lone pair electrons are not involved in resonance. So I am writing it over here. Not delocalized. So if these two electrons are not delocalized, they will be easily available for donation. That is the reason S is maximum basic. Understood? Followed by R obviously. Minus M cannot be basic, then P, then negatives. Clear? The problem is here that this SIR effect is applied. I am writing here SIR. Okay? Doubt? Alkylation of amines. See, this one is very easy. You already have learned Hoffman ammonolysis. Same way this also happens. See here. You have RNH2. Treat that with any RX. Then HX will get eliminated and R will just start replacing one hydrogen. But nothing very difficult. Okay. So it will become RNHR. Done. Again you treat it with RX. What will happen? Other hydrogen will move out. So minus HX. Another RX you give. Then lone pair will be attacking. So it will be R, N, R, R, R plus X minus. Alright, this is very easy. Nothing is there in alkylation. Now, one homework. Okay, perform the calculation and you can send me in WhatsApp. Alright. Okay, now comes acylation. That means addition of an acyl group is called acylation. In acylation, what we will study in acylation will be acylation. See, let us understand the reaction. See, we have one RNH2 and we will use RCOCl. Okay, we will usually use a base because HCl and all those will be removed by that base. Okay, so we will use a base. We usually use a strong base, that is pyridine. Okay, what happens is, let's first understand. Okay, first let me write the products, then I will tell you what happens. Product is RNH C double bond O R plus HCl. Okay, now let us understand that what exactly has happened. See here, we had RCOCl and we had RNH2. What happens is, nitrogen has lone pair and this carbon is electron deficient. So this lone pair attacks this carbon. Immediately this bond is broken. So what will form? RCO minus Cl RNH2, sorry, NH2 positive and an R group attached to it. This one will form, right? Right. Now what happens, you can see nitrogen has a positive. Nitrogen is electron negative element and it is having a positive. That is definitely not a job of that guy, right? So what it will do is, it will remove one hydrogen. Do you understand? So one hydrogen it will knock off. So if it knocks out one hydrogen, then we remain with R, mm, 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 mm. Right? This is only let me write. Understood? RNA. Now what it will happen? This minus comes down here and this gets eliminated. So what I am forming? R C double bond O NH. This was the product. Did you understand? And Cl eliminated here and H eliminated over here. So total forming is HCl. So plus HCl. Mechanism very difficult? No, I think. I'm repeating again. First of all, the double bond breaks. Right? Nitrogen attacks carbon center. So attacks and joins over there. So NH2 plus. Nitrogen being an electronegative element cannot bear a plus. Just like oxygen cannot bear, it also cannot bear a plus. So what happens is, it throws out your hydrogen and gets neutral. So RNH, that hydrogen moves out. Next step, oxygen's minus comes back and forms a double bond. So Cl is knocked out, HCl forms, and the remaining is the product. Clear? Understood? Now, let me show you the same reaction, same thing, just with anhydride. Now you see, R C double bond O C double bond O R dash. This is called anhydride, right? Now, when it is reacting with anhydride, what is the problem? Oxygen has a lone pair. These guys also have lone pair. So this will cause repulsion. That is why which bond will break first? This bond will break, either this or this. Equivalent, so break any one. So I'm breaking this. Now you can see this part is RCOO and this part is RCO. What happens is, one hydrogen comes over here. The rest joins here. How you have to remember, I'm telling you. This is a way you have to remember in the exam. Okay. What happens? This side breaks. So RC, one hydrogen comes here and the remaining whatever is left out will join over here. So what is the product? One product we got to know, RCOO R dash OH plus. Remaining part R C double bond O. Whatever is remaining, one hydrogen চলে গেলে R NH তো RNH. Got it? Very simple. This is anhydride, and previous one I showed was with acid chloride. This one is with acid anhydride. Alright. Another special case is benzoylation. Nothing. Benzoyl chloride. What is the very difficulty? Benzoyl chloride is there. Is benzoylation. Okay. So I am giving you one homework over here. This is all you have to do it in your home. Okay. Acha. RNH2. Citrate. Benzoylation. This is benzoylation. Right? Benzoyl chloration reaction will. Whatever way we have done this one, same way we do this one. Nothing to worry about. Okay? Understood? Any doubt? So this one is done. Now we'll move on to the next set of reaction, that is called reaction with nitrous acid. Very, very important reaction, because this reaction will also come in adenine as well. Remember, nitrous acid is basically what? Nitrous acid is basically HNO2, right? So reaction with HNO2 is special. Why? Because this forms benzene diazonium chloride if it is reacting with aniline. Actually it is forming diazo compound, right? What is diazo group? N triple bond N is diazo group. Okay, so you will find N triple bond N Cl minus plus minus. This will be diazo group. Now, under this reaction with nitrous acid, we will be seeing 1 degree, 2 degree, 3 degree, because the reactions are different for that. So first let us see for primary amine. Primary amine. RNH2. If I am giving HNO2, remember HNO2 can be given. Other than that, I can also write it as, I am এখানে লিখে দিচ্ছি সাইডে, HNO2 or NaNO2HCl. See, ultimately the reaction will happen and reaction will produce NaNO2, HNO2 and HCl, NaCl, sorry, right? So ultimately HNO2 I am getting. মূল কথা HNO2 has to be there. This also produces HNO2 only. But HNO2 directly I cannot give. Reason is, it gets oxidized in air to form HNO3. Okay, I am writing it over here. Oxidizes in air to HNO3. So NaNO2 slash HCl is preferred. Understood? HNO2 HCl, HNO2 is not preferred because it gets oxidized to HNO3, and HNO3 will not give the same reaction. That is why we write NaNO2 HCl, not HNO2. But you will get it in theory, no doubt. Okay, what happens is, this briefly for some time will form benzene diazonium chloride. This briefly forms diazonium chloride, Rn2 plus Cl minus. But this is unstable. This is unstable. Okay. Okay. Temperature is 273 to 280, sorry, 278 Kelvin. That means 0 to 5 degrees Celsius. So even at the 0 to 5 degrees Celsius temperature, primary amines unstable diazonium chloride. So if it is unstable diazonium chloride, what happens is the nitrogen groups readily leaves. So if we perform any sort of hydrolysis on this, then what happens is alcohol is going to get formed, nitrogen will be evolved, and HCl will be reformed. Clear? So did you understand that if it is a 1 degree alcohol, 1 degree amine, then despite giving the required conditions for diazo reaction, it will form an unstable diazonium chloride, which upon heating will release the nitrogen and alcohol will be formed. So remember, when you have to form an alcohol from a primary amine, you can use this reagent to do the conversion. Clear? So primary amine on treatment with nitrous acid gives alcohol, nitrogen evolves. This is primary amine. Clear? Clear? Next, secondary amine. Secondary amine. If it is secondary amine, then you understand R, N, H, R. This is a secondary amine, right? When I am treating it with HNO2, what forms? First, let me talk about the mechanism. A little bit of mechanism, nothing very difficult. See here, HNO2 structure key. HNO2 is HONO. This is HNO2. Alright. Now, primary amine, secondary amine is this way. Now you see what will happen is the water will get eliminated. This water will get eliminated. So moment the water moves out, what is left? NO is left, so the NO will be attached simply. So what will be attached? R, N, R, N, double bond O plus water. This is your product. Easy. This is called N-nitrosamine. Okay. So is it clear? Simple. You just remove the water from the secondary amine. The answer that you will get is the N-nitrosamine. Okay. Remember, N-nitrosamine color is yellow. It's a yellow oil. What is it? It is a yellow oil. Now the thing that I will be telling you is not very important for your ISC syllabus, because in ISC syllabus it is not mentioned, but for your JEE point of view it can be important. Put a new heading that is called Lieberman's nitroso reaction. Lieberman nitroso reaction. Okay, this is not in ISC, this is in JEE. So what does Lieberman nitroso reaction says? We got one yellow oil over here, that is this nitrosamine. This nitrosamine, this yellow oil, when if we do with phenol you all know, C6H5OH as well as H2SO4. So in presence of C6H5OH and H2SO4, in presence of C6H5OH and H2SO4, this turns into green solution. What happens? Green solution. This green solution, when I pass it through NaOH, it becomes deep blue solution. Deep blue solution. If I am diluting this solution, it becomes a red color. So, did you understand this color changes? Now, this color changes will happen only if the yellow oil is formed. And who forms the yellow oil? Secondary amine. So, this can be used as a distinguishing test for secondary amines. Used as distinguishing test for 2 degree amines. Okay. Lieberman's nitroso reaction. The yellow oil, when treated with phenol and sulfuric acid, green solution. Treated with NaOH, deep blue solution. treated diluted red solution. So this color changes will happen only if the yellow L is formed. That is only formed by secondary amines. Clear? Now let's come to tertiary amines. Tertiary amines. Tertiary amine looks like N R N R R, right? And when I'm treating it with HNO2. See, for primary amines, diazo formation you did, and then you release nitrogen and HCl. Done. For secondary amine, you have to eliminate water. For tertiary amine, you will eliminate alcohol. How? Let me show it to you. You can easily understand it. Just see. R N R R. Done. As I showed you, the structure of this will be H O N O, right? Now here, instead of water, you will eliminate alcohol. One. So what is the remaining part that will be formed? The same thing that formed in the secondary. So R N R plus ROH. Clear? So they are also giving the same product as secondary amines gave. Now the question that will arise is, if they are giving the same product, then will not they show the same test as Lieberman's nitroso reaction that has been seen? They will not show it, because in secondary amine the product that was formed was water, and this thing N-nitrosamine is not soluble in water. N-nitrosamine is not soluble in water. But here the product is alcohol, very much soluble in alcohol, so it will be difficult to separate it out from the alcohol. So if it is very difficult to separate it out from the alcohol, then how will you perform the Lieberman reaction? Clear? Okay, there it will be separated, automatically separated out as yellow. Here you will not get the yellow one only. You have to separate it. If you have to do external thing, then that is not very good. So secondary amine distinguishing test is N-nitrosamine. Clear? Okay, clear? Acha, next one question I will do. The question is NCH3, okay, and if I am reacting this with NaNO2 HCl, what will happen? What will happen? This is a 3 degree tertiary, but what will happen? Remember, I told you to eliminate alcohol when there is no hydrogen available. Was there any hydrogen available in the amine? No. That is why the OH got eliminated. That is the ROH got eliminated. But if there was a hydrogen available, like for secondary amine, see there was a hydrogen there, so did we eliminate ROH? No, we eliminated a water. So if there is a hydrogen available, we will eliminate water first, then alcohol. So is there a hydrogen available? Yes. Benzene অনেক position hydrogen available আছে. But you have to know that which position hydrogen will be taken out. That is most labile position hydrogen. You always remember, for a benzene ring, most labile position is the para position hydrogen. Okay, so always remember that this position hydrogen, para hydrogen, most labile, more labile. So if para hydrogen is more labile, then what will happen? The hydrogen from here and the OH from here will go. So remaining will be NO, and that arrow will be attaching over here. So the product will be NCH3 CH3, clear, and this is green color. So remember, whenever you have a benzene, para hydrogen you have to remove. There don't eliminate alcohol like CH, don't do that, because that will not be the correct answer. Okay, understood? This reaction is over. The next test that is coming up is the most important test that you have in your syllabus. That is the carbylamine test. One of the most favorite questions of JEE as well, carbylamine test. Carbylamine test is only given by primary amines. First point to note down, carbylamine test given by or shown by only 1 degree aromatic and aliphatic amines. So carbylamine reaction distinguishes only 1 degree amine from the others. Right? Hinsberg test, I will tell you, next one will be Hinsberg test. That will be the distinguishing factor for all three. Carbylamine reaction 1 degree, Lieberman 2 degree. Now 3 degree will be told by Hinsberg. Okay. So carbylamine test is given by only 1 degree amine, that is 1 degree aliphatic, aromatic, both of them, but only 1 degree will give carbylamine reaction. Is it clear? Okay. Acha. Another name for this reaction is isocyanide test. Okay. This test is also called as isocyanide test. Okay. This test is called as isocyanide test as well. Isocyanide test or isocyanide reaction. Okay, that's the reaction. Clear? So if it is isocyanide reaction, if it is told in the question paper, write the isocyanide reaction and also carbylamine reaction. If it is written carbylamine directly, so it's directly carbylamine. Okay. Now, what exactly is the reaction? Let us know. See, in carbylamine reaction, we have RNH2 because it is going to be only primary amine. We will be having CHCl3 chloroform, right, and alcoholic KOH. Upon this reaction we will get a isocyanide RNC, and this will be the carbylamine. Okay, along with that we will get 3 KCl and we will get 3 water. Okay, this substance is a whole smelling substance. That is why this test is been, the name has been given carbylamine. Okay, clear? Now let's understand how the carbylamine is formed. So let's dive into the, what is that called? Mechanism. See the mechanism. Chloroform we had. Chloroform. How does a chloroform look like? Cl, C, Cl, Cl, H. Done. Alcoholic OH releases OH minus, so OH minus attacks hydrogen, so water is formed. So we have Cl, 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 Cl negative plus water. What happens is this carbon throws away one Cl. So what is formed? CCl2 with lone pair, this lone pair plus Cl minus. What is this? This is a free radical. You remember, free radical we have taught you in class 11, and this is where free radicals are used. This is on one of the reaction where we will find the free radicals actually are forming. Right? Free radical, right? Then what? This is not a free radical. I said free radical, everyone is also saying free radical. What is this free radical? This is carbene. Free radical. This is carbene. Free radical also in 11 only it was taught. So nothing difficult. This is a carbene. Carbene, we have told you singlet carbene, triplet carbene, but never it came into use. This is the first time you are seeing a carbene coming into use. I said periodicals, everyone is literally saying periodicals. Okay, that should not happen anyway. Carbene. Okay, this is a carbene which is formed in this reaction. Intermediate is a carbene, not carbocation, not carbanion, but a carbene. Okay, now RNH2, RRRNH2. Right, carbene is here to attack. Carbene has a lone pair of electron, and this nitrogen also has a lone pair of electrons. Do you know that? No, nitrogen also has a lone pair of electron. Carbene is also having a lone pair of electron. So what this nitrogen will do is this nitrogen will attack this carbon now. Anyway, the carbon is short of electrons. Okay. So what happens is R N H H, nitrogen gets a positive charge, carbon gets a negative charge, and 2 chlorine as well as it is attached. Right? Right? Okay. Now let me move on to the next slide. Just copy this slide. Okay, I'm continuing. OH minus, don't ask me where it came from. This H it will take away. So what it will form? RNH. C minus, Cl, Cl. One Cl knocked out. So what it form? RNH, CCl. Right, now this nitrogen has a lone pair donated over here. So what it formed? Rn plus H double bond CCl. Acha, OH minus is there, attacks hydrogen. So what it forms? Rn, again 2 lone pairs CCl plus water. Now here this lone pair is donated over here again. So ultimately you can see Rn triple bond C, and this Cl is knocked out. So Rn triple bond C plus HCl. HCl will actually not be there. Cl minus I'm writing. HCl will be formed. Okay, this is the final product. Clear? 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 RNC will be the final. This is the entire mechanism for carbylamine reaction, which you have to remember. For JEE, not for ISC. Alright? Clear? Carbylamine reaction clear? Hinsberg test. Very important. Very important Hinsberg test, because one question will definitely come on inverse test. Okay. Now Hinsberg test is basically distinguishing test between 1 degree, 2 degree, 3 degree amines. The group reagent that we use, it is benzene sulfonyl chloride. Benzene sulfonyl chloride. Okay, I think it's not readable. Let me rewrite. Benzene sulfonyl chloride. Benzene okay, this will be the group reagent. Now let me just quickly summarize one thing. Let me summarize what is the test showing. If it is a 1 degree amine, 1 degree was done treatment with CC-5 SOCl KOH, clear solution followed by HCl insoluble. Okay, if it is a 2 degree amine, then C6H5SO2Cl KOH insoluble, HCl insoluble. If it is a 3 degree, C6H5SO2Cl KOH, no reaction. Okay, no reaction. That means actually it will be insoluble. Common sense also will be used. It is not showing any reaction, so it will be insoluble in that, right? And if you acidify it, you will get a soluble one. It is clear solution. Why? Due to formation of tertiary salt, nothing difficulty. Clear solution. So this is the way that you will be differentiating between 1 degree, 2 degree and 3 degree amines using Hinsberg method. Okay, very important. This is Hinsberg method. Okay, Hinsberg test clear. Now then let's just quickly see the reaction. RNH2. This is going to be the 1 degree one. Benzene sulfonyl chloride SO2Cl. This Cl and this H. One Cl and one H will move out, so it will form HCl and go out. Okay, so I am writing minus HCl. The remaining part will join over here. Right? Now this one, when I am treating it with KOH, then this hydrogen is acidic hydrogen, so this will get replaced by K positive. So this is soluble. Okay. Acidic hydrogen gets replaced by metal ions. This is what you have learned in class 10. Acidic hydrogen gets replaced by metal ions. So this is acidic hydrogen. Now how will you identify whether hydrogen is acidic or not? Acidic hydrogen means hydrogen is attached to a highly electronegative atom. Nitrogen is an electronegative atom. Right? So it is going to be the hydrogen going attached to nitrogen is going to be an acidic hydrogen. So this is going to be soluble in the alkali. Now when I am going to treat it with HCl, then what will happen? This K will take the Cl and move out as KCl. So again there is going to be an insoluble precipitate formed, right? That is again going to be this one. SO2 NH. This is insoluble and KCl will move out. Clear? So this is the reaction of 1 degree amine with Hinsberg reagent, that is benzene sulfonyl chloride. Now come to the second one, that is RNHR. This is a 2 degree amine. This one when I am treating it with benzene sulfonyl chloride, that is SO2Cl, then what will happen? H and Cl moves out, so remaining part will join, so it will happen SO2N R. Now when I am treating it with KOH, will I get anything replaced? No, because no acidic hydrogen is there, so the potassium ion will not enter only, so it will remain insoluble. SO2 NR. That is why we have told you that 2 degree amine insoluble in both the cases, because there is no replacement happening. So if I put even HCl in this, then also it will remain insoluble, nothing will happen. SO2 NR. Okay, insoluble, insoluble. Why insoluble? Because acidic hydrogen is absent. I am writing here acidic hydrogen absent. Okay, so if acidic hydrogen is absent, then there is no question of happening, right? Next, 3 degree RNRR, this is going to be a 3 degree amine plus benzene sulfonyl chloride, no reaction. Why? Because there is no hydrogen only. HCl first step এ HCl টা বেরোবে, that is only not happening. Why? Because no hydrogen is there only in the original compound. So that is why first reaction does not happen. Okay, first reaction does not happen means in presence of KOH this will not happen. Okay, this one is just an intermediate. Actually we are doing with KOH, na? This is just an intermediate being formed. Anyway, so no reaction happening with KOH, but if I pass this on to the next step, that is with HCl, then I will get one soluble precipitate. Why? This lone pair is there, HCl's lone pair H is acidic because again Cl is very electronegative, so H is acidic, so this H comes over here. So what will happen? I am writing in this way, R3NH plus and Cl minus. This is a soluble. That is what I have written. That 3 degree no reaction, that is insoluble. Secondly, clear solution. Why? Due to the formation of trialkyl ammoniate. Okay, this one is trialkyl, trialkyl salt. That is why we have found this. Clear? This is a reaction of Hinsberg, which you should know. Acidic hydrogen present. That is why here the potassium ion is getting replaced. In 2 degree there is no acidic hydrogen present, so even in alkali it is insoluble. And 3 degree no reaction with the alkali because initially only no hydrogen is there. Initially only HCl that will be really, that is only not there. Then how will the reaction proceed? Is it clear? Is it clear? Okay. Next we move on to aniline. Before that let me show you the syllabus once. This is your ISC syllabus. Okay. This is your ISC syllabus, not JEE mains. See, nomenclature class 11. So that I will not do. These things class, okay, GOC lecture is there. Method of preparation: alcohol done, alkyl halide done, cyanide done. This one is Hoffman ammonolysis. Hoffman ammonolysis. Cyanide done, Hoffman degradation done, nitro compounds done, Gabriel thalidomide done. Right? Extra we also have told you, which is in JEE. Next, physical properties we have covered. Comparison between primary, secondary, tertiary amines done. State, solubility, boiling point, hydrogen bonding I have told you. Comparison with alcohol, that is amines will have a lesser, comparatively lesser boiling point than alcohol, because alcohol hydrogen bonding is from the O center while amines is from the N center. Told already, right? Now come to chemical properties. Basic character amine discussed. Comparison with primary, secondary, tertiary amines, ammonia, aniline, whatever. Effect of substituents and the basic strength of aniline. I have told you basic strength proportional to plus I effect minus I effect, inverse proportion. Alkylation, acylation with mechanism discussed. Reaction with nitrous acid discussed. Carbylamine reaction discussed. Distinction, this is very important. Distinction in primary, secondary and tertiary amines, Hinsberg test discussed. Done. Okay, so now let us move on to the next topic that we have is aniline preparation, cyanide, diazonium salt. We have almost come to the half of the chapter. Okay, so now let us move on to aniline, preparation of aniline from nitrobenzene. See, preparation of aniline from nitrobenzene, I think I have already told you before. From nitrobenzene, if you have to prepare aniline, then only and only acid medium will be done. Okay, if you are using any other sort of medium, then you will not get aniline, you will get something else. That I will show you right now. So I write down first point, aniline can be prepared. Aniline can be prepared from nitrobenzene in acid medium only. Okay. So if you are giving any other medium, the product you will get is different. I will show you how the product will change according to the medium. So the reaction that you have to remember is NO2 plus 6 nascent hydrogen in presence of tin HCl, you will get is aniline plus 2 water. Okay, 4 plus 2 6. Huh? Okay, did you understand this? This is the reaction that you need to remember. Nothing else you will remember. You will remember this reaction for your ISC. Simple. Okay, now let us see that how according to the medium the reactions of nitrobenzene is different according to different reactions. Okay, acid medium to already shown, still I will show it over here. Heading will be reaction of nitrobenzene, reaction of nitrobenzene in different medium. Okay, let us see how nitrobenzene is going to vary with different mediums. Let's see. First medium. Number one, acid medium. If it is an acid medium, then already you know what will happen. SnHCl, right? Clear? This is an acid medium. Now next medium. Next medium is, let us take neutral medium. Basic I will come last. Neutral medium. These reactions are not in ISC, okay? So no need to worry. Byproducts I am not writing. Neutral medium, NO2, two reactions I will show. So reaction 1. If I am giving zinc and ammonium chloride, what I am giving? Zinc and ammonium chloride. If I am giving zinc and ammonium chloride, then partially this NO2 will get reduced. What did I say? If I am giving zinc or NH4Cl both, then the NO2 will get partially reduced. Understand this thing. Partial reduction means one oxygen will stay and the other will go. Complete reduction means both the oxygen disappear and hydrogen enters in its place. Right? Here, one oxygen will stay and the hydrogen will enter. So, nitrogen has, let us take two hands like this with oxygen. One will be double bond obviously. So, one oxygen disappeared. So, one hand is empty, and one bond will break here also. So, another hand will be open. So, two hydrogens will enter. So, it will be NHOH. I showed the wrong diagram. Let us see it again. This way. So, this oxygen will break up first. So, NHOH, H. Clear? Okay. So, the product that will be there will be NHOH. This is known as N-phenyl hydroxylamine. N-phenyl hydroxylamine. Okay, so remember zinc, NH4Cl or NH42 sulfide, is all I am giving is partial reduction. So they will not completely reduce it to aniline but NHOH. Clear? Next. Second reaction is if I am giving iron along with water in gaseous state, then I will get nitrosobenzene. That means NO. Nitrosobenzene. Did you understand? So in acid medium, you could see aniline directly coming up. in neutral medium, we are seeing that partial reduction happening, NaOH is being formed. If we are giving zinc and NH4Cl, if we are giving iron along with H2O in gaseous form, H2O vapor, then you are getting nitrosobenzene. Now let us see, if it is a basic medium, then what will happen? The basic medium is an important reaction, because later on I think uh, not probably not in IC syllabus, coupling is there but not in IC syllabus. You are having coupling with only phenylalanine. This is some other coupling. Okay, basic medium. In basic medium, coupling will happen. What will happen? Coupling happens. Coupling means, what is coupling? In literal sense also, coupling means what? Two persons coming together of opposite gender. It is a couple. Right. Here also coupling means two same or two different might come together. Two same compound or two different compound might come together and merge. That is called coupling. It will join. Okay. So, nitrobenzene, if I treat nitrobenzene with Na3ASO3 and NaOH, Na3ASO3, NaASO3, sodium arsenite and sodium hydroxide, then there is a coupling happening. What is the coupling? Let us see. My benzene looks very dangerous in horizontal position, so forgive me for that. Okay. N double bond N, and there is a coordinate bond with O. This is called azoxybenzene. See, if this part was not there, let us assume that this part is not there, then the name would have been azobenzene, right? So there is an extra oxygen, that is a azoxybenzene. Azoxybenzene. So did you see that two structures are just joined? This is known as coupling. Another one, let's see. NO2, if I am treating it with zinc NaOH, zinc plus NaOH in presence of methanol, then also coupling will happen, and this time the coupling that will happen will form azobenzene, not azoxybenzene, azobenzene. So if it is a azobenzene, what will be the change? This person will not be there. So this is known as azobenzene. Clear? So if I am giving sodium arsenide in presence of sodium hydroxide, I am getting azoxybenzene. If I am giving sodium hydroxide plus zinc in presence of methanol, then I am getting azobenzene. Okay? Another reaction is there. NO2 in presence of only zinc sodium hydroxide. Last reaction you see, zinc plus sodium hydroxide in presence of methanol in presence of acid. Here zinc plus sodium hydroxide, nothing in presence of nothing, only this much. Then only it become base presence. This become a presence of base, right? So this will form. Let me just copy this. देखा क्या? This was azobenzene. Here this double bond will not be there, and what it will form is NH. This is called hydrazobenzene. Hyd for hydrogen, hydrazobenzene. Clear? So if you are giving only zinc and sodium hydroxide, you are getting hydrazobenzene. If you are giving zinc and sodium hydroxide in presence of methanol, you are getting azobenzene. And if you are giving sodium arsenide in presence of sodium hydroxide, you are getting azoxybenzene. So you can see that if I am changing the medium, The product is different, but what we have in our syllabus is only acid medium. That is preparation of aniline from nitrobenzene, because those products are not not aniline, they are non-aniline products. Clear? So reaction is clear to you. You have to know these reactions for your JE and NEET. Done. Okay. Now let us start with the chemical properties of aniline. We have finished with the introduction, the method of preparation of aniline. Physical properties, just give it a reading because I don't have anything to explain over here. It's written. Notes will be reaching to you. Just check it out over there what is written. Or you can just pause the video now and you can just read it what is written, because nothing I have to explain. Already I have written to save the time. Okay, just check it out later on. Now let us come to the important thing, that is chemical, because I don't want to extend the video much. I just trying to shorten it up. Okay, chemical properties, reaction with HCl and H2SO4. Now you see, as I have already told, that derivatives of ammonia, that is aniline, and all amines, they are behaving as a base. They are basic character. So if you are having a basic character of amine and acidic character of HCl, then what will be the reaction? Very simple reaction, right? So let us see the reaction. NH2 plus HCl. What will happen? This Cl will be taken by one H. It means HCl will be reformed. HCl is supposed to be reformed, but it will not. Why it will be reformed? We are already giving it. Why will it be reforming? Then nothing has happened. The reaction is not happening. Right? Nothing has such. So what will happen is HCl will get added. HCl will get added. This is a base. So this lone pair will get donated over here. This lone pair will get donated over here. So hydrogen will add up over here. So what will be the product? The product is going to be an additive product. It will be NH3 plus and Cl minus. Clear? Or you can write this also. You can write this as NH2 dot HCl. This is also accepted, but that dot has to be there in between. Either you write it that way or you write it this way. Both the ways are correct. So if I am giving you sulfuric acid, then what will be your answer? If I am giving you sulfuric acid, then what will be your answer? Procedure is same, but the product will be different. Why? Let us see. NH3 whole 2 positive, SO4 2 negative. Why? Because SO4 is 2, so it needs 2 NH3s, not 1, right? It needs 2, not 1, right? So in the exam, suppose this question has come, this is a question of the exam, and you will write this. You will write this, and this is a common answer. This is a very common answer, and you will write this, and you will get a big 0 over here. Then you will come complaining why you got 0 over there. I have written correctly, but why did you get 0? Now you see where you made the mistake. You have written NH3 whole 2. Very good. Only the NH3 part is whole 2 and the benzene ring is only 1. Is it possible that the benzene ring is 1? See, benzene ring is 1 and 2 NH3 on it. Where did it come from? Only one NH3 was there. Where did the second NH3 come on the same benzene ring? Use your brain sometimes. So this is possible. No. Then what will be double? The entire thing is doubled. So you have to write in that way now. So this is a very common mistake which you are supposed to do. So don't do this mistake, and this will get you 0. This will get 0 in the exam. So what will be the reaction? The reaction will be NH2 plus H2SO4 additive product. So you write C6H5 NH2 whole 2 plus SO4 2 minus, or C6H5 NH2 whole 2 dot H2SO4. Is it clear? You cannot only write NH2 whole 2 and the remaining one benzene ring is 1 and only NH3 whole 2. Does not make any logic. কোনো সেন্স হয় না কথাটা। বেঞ্জিন রিং একটা থেকে দুখানা NH2 পেলাম কোথা দিয়ে? ছিল তো না কোশ্চেনে। তাহলে then you have to write entire thing as whole 2 then plus NSO4 2 by. Now it is correct. Okay, so please don't make this mistake in the exam. Okay, next reaction, alkylation. See, already I have discussed, too many times I have discussed amine alkylation in the, when we were discussing aliphatic amines, there I have discussed alkylation. See, mm, here you go, alkylation of amines. So you can see the same thing will happen here also. Only one R will become what? It will become a aniline. So it will become benzene. Same thing will happen here also. Whatever we have done there, here also will do the same thing. So alkylation, we have aniline. Let us give Rx. So what we will get? Right. And here there will be HX out. Again we will give HX. Sorry. Again you give Rx. Minus HX. Again you give Rx. Clear? So same thing we have done for aliphatic amines. Now we are doing it for aromatic amines. Difficult? Nothing. Next one, acetylation. It means introduction of acetyl group. Introduction of acetyl group is acetylation. So how will we introduce acetyl group? NH2 plus CH3 COCl. Introduction of acetyl group. So what will form? This Cl and this one hydrogen gone out as HCl. So formation will be the remaining one. Sorry, NHCOCH3 plus HCl. See, no need to mucosto anything. You not mucosto. What did we do? Cl and one hydrogen eliminated. Remaining whatever was there, we have written in ditto. Ditto copy. But when you are writing it, you have to understand that from which side the bonding will start. Here the chlorine is attached to oxygen, so oxygen is half khali, so don't attach it from the carbon side, then it is wrong. To attach it from the oxygen side. Clear? Okay. Okay. So this is acetylation. Simple, nothing difficult. Next one. Benzoylation. Benzoylation is a special case of acetylation only. Benzoylation will be a special case of acetylation. Acetylation, we are introducing an acetyl group. Benzoylation, we will introduce a benzoyl chloride. Simple. So, we have aniline and we will be introducing benzoyl chloride to it. Benzoyl chloride means this one. So, what will happen? Anything difficulty will happen. In presence of NaOH, this reaction is done. Huh? Remember, this reaction is done in presence of NaOH or pyridine. This reaction also we can do in presence of pyridine. Okay, or pyridine. Okay, we can do it in presence of pyridine also, but I am not writing that. I am writing NaOH only. So what will happen? Cl and H gone. Remaining part will join. So what will be the product? Product will be C6H5COCl. Sorry. NH remaining COC6H5. Right. Now remember this reaction, benzoylation of aniline in presence of NaOH. So I am writing here benzoylation spelling is dying. Benzoylation of aniline in presence of NaOH. This line is important. Benzoylation of aniline in presence of NaOH. Then we will call this reaction has got a name. This reaction is called Schotten-Baumann reaction. This reaction is called Schotten-Baumann reaction. So if it is coming name reaction, then you cannot write pyridine. That is why I did not write pyridine. Because if you write pyridine, it is not Schotten-Baumann reaction, but it is a benzylation reaction. So Schotten-Baumann reaction is for NaOH in presence of benzoyl chloride. Clear? So benzylation of aniline in presence of NaOH is called Schotten-Baumann reaction. Baumann, Baumann reaction. Okay, this one is clear. So benzylation is basically a special case of acetylation. Now here I will give you two homework to do. Not two, one only I will give. Do tell me the answer of this, because this can be one question. This is an important question. Suppose I have given aniline, but instead of acid chloride, I have given acid anhydride. What I have given? Acid anhydride. Now you think and tell me what the product will be. You tell it me in my WhatsApp. Okay? Think this question, because this might come in the exam. This is an important one. Okay, so aniline in presence of acetic anhydride, not chloride. Now think what can happen. Though I will eventually give this answer later on, that I will have to. Okay, now come to carbylimine reaction. Now see, carbylimine reaction, to how many times I have told? Two times I think. Previously one time I told. Carbylimine reaction remains same, nothing different. Just instead of methylamine, we are using aniline. So carbylamine test is shown by only 1 degree amine. I have told you that it will be shown only by 1 degree amine. So aniline is a 1 degree amine. This is why it will show this test. So what was the reagent we used? CaCl3 in presence of alcoholic KOH. So what we will get? We will get an isocyanide. That is going to be N triple bond C plus 3 times KCl plus 3 times water. Done. Next reaction, diazotization reaction. Now you remember in diazotization, that is reaction with nitrous acid. This we learned as reaction with nitrous acid. This heading was there for aliphatic amine, because there diazo is not formed, unstable diazo is formed. No, reaction with nitrous acid. So here we will show the reaction with nitrous acid, but here diazo will form. So in aliphatic amines, we have seen diazo was not stable, though it was not stable. But here in aniline, diazo is stable at 0 to 5 degrees Celsius. Let us see. Aniline we have here. Aniline is a very bhayankar dekhte aniline. Right. So here we have aniline in presence of Na, NO2, HCl. It forms benzene diazonium chloride. Now, if you write only this much in your exam, you will get what? 0. Or if the teacher wants, he can give you half. Though it is not supposedly to be done. Why? Because it is very, very important to mention the temperature when you are writing diazotization reaction, because diazo is stable only at that particular temperature. If you increase the temperature, it will not be stable. Nitrogen gas will be evolved. So if you are not mentioning the temperature when you are writing diazotization reaction, you will get a big 0 in your exam. Is it clear? So temperature, I am writing here, temperature must be mentioned. Temperature must be mentioned. Clear? So when we will be writing the reaction should be like this. NaNO2 HCl 0 to 5 degrees Celsius or 273 to 278 Kelvin. That does not matter, but that temperature should be mentioned in your answer. N2 plus Cl minus. This is called benzene diazonium chloride. Benzene diazonium chloride. Okay, now in some places you will find it is given HNO2 directly. It is given HNO2 directly. In that case, when you are forming the diazo at 0 to 5 degrees Celsius, when you are forming the diazo, you will write only N2 plus. Listen to me first. When it is given NaO2 you are writing N2 plus Cl minus. Fine, very good. When it is given directly HNO2, 0 to 5 degrees Celsius, you will write only N2 plus. Why? Because what is the anionic part that has not been told to be in the reagent? In the reagent, it is told to be in the reagent. No, but here you can see it's told in the reagent HCl. But here in the reagent, nothing has been mentioned, so we will not write any anionic parts. Any anionic part we will not write, because whether it is Cl, Br, HSO4, BF4, whatever it is, we don't know. So we will not write, we will not go for any risk, we will not write any anionic part if it is given directly HNO2. If it is given, the anionic part is mentioned in the reagent, then you obviously have to write it. Clear? So just have a look at this. Okay. Achha. Now let us move on to the mechanism part for this. Take a fresh page. Mechanism. Achha. Before I start the mechanism, why is this diazo stable? Due to resonance. I think you can know. You by now you know what is resonance. So this diazo is stable at 0 to 5 degrees Celsius due to resonance. Okay. We increase the temperature, the nitrogen gas will be involved. Okay, fine. Let us come to the mechanism. Achha. This reaction is an example of electrophilic substitution reaction. Okay. If it is an electrophilic substitution reaction, then there must be an electrophile. So first we have to generate the electrophile. How will we generate the electrophile? We will generate the electrophile in such a way. Let us understand how. First of all, you have to know HNO structure. HNO structure, if you have drawn N double bond O H, right? I am giving a H plus. Where I am getting the H plus from? I am getting the H plus from HCl, right? Okay. H plus is there. Now, this nitrogen, sorry, not nitrogen, oxygen, because oxygen electronegativity is higher. So, before nitrogen, oxygen will donate the electron pair, right? So, oxygen donates its electron pair to this hydrogen. So, what we are getting is ONOH2 positive. Now, you know that oxygeনের মাথায় ever positive is coming, then what it will do? It will immediately move out. It is immediately going to break that bond and move out. OH2 is water, so this will immediately move out as this. So I have got the electrophile, that is N double bond O plus. This is my electrophile, and water has already been formed over here. Okay, so this person is my required electrophile. So it will attack the electron rich center. So electrophile will attack immediately NH2. So NH2 is there present. NH2. NH2 has this lone pair, nitrogen is having, and NO plus needs electron. So this lone pair will be here coming. Okay. So what will happen? This will join. So NH2, N will get a positive charge, and N double bond O will be joining in. Right. Now, oxygen has a lone pair, right? And these hydrogen are acidic hydrogen. Why reason I did not say? Because nitrogen is electronegative atom. So hydrogen attached to this one will be electronegative atom. Sorry, acidic hydrogen. So oxygen takes up one hydrogen. So what will happen? N. So what will happen? N will remain with only one. So NH. I am writing it straight. ওপরে লিখেছিলাম সেটাকে সাইডে করে দিলাম। উপরে লিখেছিলাম সাইডে করে দিলাম, ঠিক আছে? তাহলে NH, then what will have remain? N double bond O plus H. Check. Correct. This hydrogen is also acidic. This hydrogen is also acidic. So this hydrogen exits. This bond shifts over here because oxygen's plus, so it will not exist. And OH minus is not a good living group. So OH minus বেরোতেও পারবে না, আবার অক্সিজেনের মাথায় প্লাস হলে অক্সিজেন is getting mad. So oxygen cannot have a plus on its head. So oxygen is going mad, but OH minus is not a good living group, so it cannot exit as well. মানে আরেকটা হাইড্রোজেন it will need to exit, but it does not have. So this will be forming what? n এর মাথায় চলে গেল, n will get a positive, that means n will get a lone pair. Actually I am showing it with a lone pair, I am not writing a minus, huh? It will actually give a minus, but I am showing by a lone pair. Okay, n will get a positive and OH. ঠিক আছে, this product is from, now see, nitrogen, here you see this nitrogen donated is lone pair. এই হাইড্রোজেনটা যখন বেরোলো তখন হাইড্রোজেনটা তো একে ইলেকট্রন পেয়ার দিয়ে গেছে, তাহলে এর কাছে ইলেকট্রন পেয়ার, এখানে একটা ইলেকট্রন পেয়ার চলে এসেছে এর কাছে, সো ইট ইজ হ্যাভিং ওয়ান ইলেকট্রন পেয়ার। ভালো করে বুঝবে কিন্তু ইলেকট্রন পেয়ারটা ইজ নিডেড। সি এর কাছে ইলেকট্রন পেয়ার ছিল এখানে দুটো, একটা সরি, ডোনেট করে দিল, প্লাস হাইড্রোজেনটা যখন এখান থেকে বেরোচ্ছে দেখুন হাইড্রোজেনের দুটো ইলেকট্রন এর কাছে এলো, so it is now got having two electron already. Now this hydrogen is also leaving, so two more electron it is having. Correct? বুঝছে না ভালো করে এগুলো, ঠিক আছে? তাহলে this two electron it is already having on the second hydrogen, but the first hydrogen two electron it is giving to form a double bond. ঠিক আছে, তাহলে the question mark that can come in your mind is double bond, where did it come from? Double bond came from here. These previous two electrons that made the double bond, new hydrogens two electrons are there with nitrogen. Is it clear? Clear? Okay. So this one is the final structure that I am getting now. In the solution, H plus is available. Oxygen has a lone pair. Attack this hydrogen. So what it will form? N double bond N OH2 plus. Now oxygen again got a plus, but OH2 is there, so it can exit. So it will exit as N double bond right, this will form plus. So now this lone pair comes over here, so ultimately I am getting, this is my benzene diazonium chloride. Is it clear how benzene diazonium chloride is formed? This is benzene diazonium chloride. Benzene diazonium chloride is not there, so I am not mentioning. Okay, so did you understand the mechanism? I am re-explaining the mechanism. Please listen to me very carefully. Okay, because I know this might be a little bit complicated, so let me just re-explain. See, acha, this is HNO2. You can see oxygen has one lone pair. That lone pair electron went to the hydrogen that was present in the solution from HCl. Done. So H plus will now attach to OH. OH2 সাথে attach করে গেছে, this one. Now oxygen has developed a plus charge. Now plus charge on oxygen means it will go mad. But OH2 is also there, and OH2 is a very good leaving group. So this leaves, right? Moment this leaves, nitrogen develops a positive charge. So NO plus, and NO plus is only the electrophile. NO plus is the required electrophile for this reaction. Okay, now electrophile will attack electrodrift center, that is aniline. So aniline is here. Aniline's nitrogen has lone pair, so this lone pair attacks NO, then nitrosodium ion attacked. Now যেই অ্যাটাক করলো, NO will get attached to NH2, এই যে অ্যাটাচ হলো, তাহলে NH2 N will get a plus charge and NO attack. Now nitrogen attached hydrogen is acidic hydrogen. Oxygen is having a lone pair, so oxygen takes away one hydrogen. Moment this one hydrogen exits, the hydrogen's two electrons, it is one by the nitrogen and one by the hydrogen itself, is coming back to nitrogen. So the plus of nitrogen is gone, and two electrons that are coming to nitrogen. Those two electrons are these two electrons. Please be very careful. One hydrogen is exiting, so those two electrons are coming to the nitrogen. So these are the two electrons coming to the nitrogen. Understood? Fine. And oxygen is getting a plus charge. Oxygen has one hydrogen double bond. Now oxygen's plus means oxygen will go mad, but despite going mad it cannot exit. Why? Because OH minus is not a good leaving group. OH minus is not a good leaving group, so OH cannot exit even if it wants to, so it must form OH2 to exit, right? So this cannot exist. So what happens is this double bond that was present, this breaks. Double bond breaks. So now oxygen plus is Shanti, no more Ashanti. This hydrogen present or this nitrogen is acidic again. So this hydrogen exists. This hydrogen exists. So nitrogen has got two more electrons. Out of that, two electron it gives to form a double bond. Double bond. Two electrons are remaining. OH, right? This exited as H plus. So let me write it over here, minus H plus. This person exited as H plus, which this H plus will be eventually taken by the OH only. That I have shown in a separate step. OH again gives the lone pair to this H and forms OH2 plus, which ultimately exists as water. Now you can see that this nitrogen has a positive charge on it, positive, and this nitrogen has a lone pair. So lone pair donated, triple bond. This nitrogen's positive charge gone, but this nitrogen got a positive charge now. So this is N triple bond N, and this is benzene diazoniamine. Is it clear? This is the mechanism of diazotization reaction which I want to study. Now from this diazo, there can be many products that will be formed from diazo. Okay. Next topic is electrophilic substitution reaction. Now, electrophilic substitution reaction means what? In our ring, there will be electrophile attacking and attaching to the ring. This you have done in class 11 also. Same thing, okay? Mechanism refer to class 11 because I will not show the mechanism here because it was done in class 11 already. Okay. Now you see, we have only three type of mechanisms. What are those? Not mechanisms, sorry, the reactions. See here. What reactions we have? Preparation of aniline done, physical property, state, solubility, boiling point done, chemical property, reaction with HCl done, acetylation, alkylation done, benzoylation done. This was called Scott and Bauman reaction. Scott and Bauman. Carbylamine done, diazo done. Electrophilic substitution we are having bromination, nitration and sulfonation. So we'll be reading those three. Okay. So first let us understand about bromination. So see here, bromination. So let us give the heading bromination. Now you see, we are having, let's take, suppose first let me give you an example of class 11. Okay, we have benzene and on that if we are giving FeBr3 and Br2, class 11, Br will be formed, correct? Haloalkane, haloarine, the same reaction we did with bromo already. Then what will happen? This one, ortho and para directing. So Br, this will be the major product, this will be the minor product, right? This was in haloalkane, haloarine. Now here we will not have this in Br, we will have here NH2. Simple, but it will not be that much simple. Let us understand why it will not be that much simple. So we have aniline, and if we give Br2 in presence of FeBr3, then the product we should have got was NH2Br, major, right? NH2Br should have been the major product that we should have got, but we will not get this product. What will happen? We will not get this product. So if we are not getting the product, what we will get? We will get the product of something else. Let us see the product. So what we will get is, we will get this NH2, Br, Br, Br. So you can see, or this is white in color. So you can see that all the positions have been substituted by bromine. This is what happens when you give bromine with FeBr3. Why? Because this is a strong activating group. This is a strong activating group. This is a strong activating group. Ortho-para directed activating group. Okay, that is why all the ortho and para positions are substituted. But this is not what I want. right? I want NH2Br. So how will I form? So in this condition, we will protect the NH2 group first. What we will do? We will protect the NH2 group by acetic anhydride. So first we will do protection of NH2. Protection of amino group. Protection of amino group. How will we protect amino group? See here. First of all, the reaction we will do with is acetic anhydride. CH3COOCOOCH3. This is known as acetic anhydride. Right? So first we have done the reaction with acetic anhydride. So what will happen is, I have already shown you, right? I think I gave you this question as homework, that what will happen if I give aniline with acetic anhydride. What will happen? This bond will break, this part will attach, and one hydrogen will go here to form CH3COOH, right? Right, this bond will break, so here our hydrogen will come, acid will form, and this part will go and attach over here. So what will be forming? NHCOCH3. This I have already shown. Right, along with that the byproduct is that I am not showing. So this one is protection. This step is called protection of amino group. Now this guy, that is NHCOCH3, this person's activating power is less than activating power is lesser, comparatively lesser than NH2. Okay, so it is comparatively lesser than NH2. Now to this compound I will give Br2. Okay, in presence of CH3COH, or I can give it in presence of FeBr2 as well, no problem with that. Okay, now the product that I will get is NHCOCH3 Br. That will be my M. I am writing for major. Okay, how will you know? Always both are M. Okay, major plus NHCOCH3 Br for minor. Okay, now we did not get NH2. How will we get NH2? Simple. Just we need to hydrolyze this. Acid hydrolysis. Here you can see that acid went out. So do acid hydrolysis. So if we do acid hydrolysis of this, then what we will get? I am writing the major product. Kindly write the minor one also. So we will get NH2Br plus another one. Write down the other product. So did you understand that how did we do the bromination? Directly if we do the bromination, we will end up getting this product, which we do not want. So we are protecting the amino group at first by reacting it with acetic anhydride. Then we are reacting with FeBr3. Is it clear that why we are protecting? Because we have to form a para product, not a completely substituted product. It's mono substitution you have to form. Okay, not tri substituted products. Clear? So same thing will happen for nitration as well. If I want to do nitration, then also the same thing I will do. First I will do the reaction with acetic anhydride. I will protect the group. Then I will do with that. Right? So I am just copying these slides because you see it will be the same thing. So I am just copying this slide. No. See here. I am removing this because this I am not writing anymore. I am writing a nitration directly. Okay. So second one we are coming to now, nitration. Okay. Now see here that this part is not changing. First part, this part will not change. Whatever we have done, that will be same. What will change is the reagent over here. The reagent will not be FeBr3Br2. What is the reagent? The reagent is concentrated H2SO4 and concentrated HNO3. I hope you remember class 11 something at least. So this will be your. So what will happen? So here let me remove this. This will be minor anyway. So here I will put NO2, which will be a major product, and here I will put minor product. It will be NO2 over here, right? Upon hydrolysis, this will become NO2. Minor product, I hope you will write it. Okay, so nitration is same. First step same, reagent. Second step reagent I have changed to whatever I need. This will be concentrated HNO3. Concentrated HNO3. Okay, this I think you have done in class 11 already. Acha. Now, if this was not this, then what I will get? Like, if I have not protected the group, then what will I get as the product? That also you need to know. So if I do not protect this amine group, then the product that I will get is here. Suppose I am using directly on this concentrated H2SO4 and concentrated HNO3. Then what product I will get is NO2, NH2, NH2 I will get NH2, NO2. That too obviously I will get, no doubt. Another product I will get NH2, NO2. Fine. Another product in additional to this I will get is NH2 meta directing NO2 also I will get in a good number. Okay, so this is around 47% of total reaction. Para is 51% and ortho will be less because this is not going to be formed. Okay, so why is this para directed product being formed? Para directed product is being formed due to the anilinium ion. This will get oxidized to give you, this will release H plus, so ultimately the H plus will come here from any linium ion which is not stable, and that is meta directing. So a meta product is formed, though it is not a major product, but it is formed, and we don't want meta products. We want the para product to be the major, though it is major here also, but we don't want the meta product. So we are going by this thing. Is it clear? Nitration, is it clear to you? Clear? Next one, sulfonation. Sulfonation is a little bit different and it is an easy one. Sulfonation. If I go for sulfonation, then the reaction that will take place is Cl, NH2. On this, I will directly give concentrated H2SO4. Now you tell me. Concentrated H2SO4 is a proton donor. Proton donor. It is a proton donor. So if it is a proton donor, then it will give H plus, and this is a base, so it will accept H plus. So this thing will form, so this thing will form NH3 positive, HSO4 negative. Tell me, will it H2SO4 থেকে if I am releasing H plus, then remaining part is HSO4 minus, that will come there, and this will form NH3 plus, right? This thing, if I am heating at 453 to 473 Kelvin, then what I get is, I get this product, that is NH2. This part is here, NH2. SO3H is the product that is supposed to be from sulfonic acid, so that will come over here, SO3H. Okay, and water will go out obviously. Acha. So this will be the product that will be formed. Now you tell me, this is a equilibrium step. See here, NH2 is a acidic center, basic center, and SO3H is the acidic center. This acidic hydrogen. So what will happen is, this will exist as this format, NH3 positive and SO3 negative. This thing in chemistry we call it as Zwitter ion. This thing in chemistry we call it as Zwitter ion. Zwitterion means according to the pH they will change. Okay, if I give acidic pH, then this will be forming. If I give basic pH, this will form. So according to the pH, it will change. Where else you can get in chapter biomolecules in amines, amines I'm saying amino acids, you will get the same thing. Amino acids as acid and NH2 terminal, so they are also zwitterion. They will also exist as zwitterion. So sulfonation is a clear. Okay, sulfonation clear. Okay, right. So we are done with sulfonation. After sulfonation, we have only two small things that are left. That is test for aniline and usage of aniline. So test I will talk about right now. The usage of aniline is very easy. Nothing, just you have to read. Test for aniline. See, first test that we can perform for aniline is carbylamine test. Do I need to explain carbylamine test again? I don't think so because I have already explained it two times. Carbylamine test. So you can use carbylamine test. You will get a foul smelling substance, that is carbylamine, that can only be given by aromatic amine and the aniline, right? Second test that you can do is coupling with beta naphthol. Coupling with beta naphthol. Reactions are not required actually. Naphthol, no reaction required, only observation. So when you couple with beta naphthol, then you get a orange color dye. Orange dye. This color you need to remember. Okay, orange dye you are getting, this color you need to remember. So when you couple with beta naphthol, you get a orange dye. Okay. Third reaction is aniline plus sodium hypochlorite. Sodium hypochlorite solution. If you add, then you will find, violet coloration to brown. Okay, so we will find violet coloration to brown coloration. So this is a color change observation. So this can be acting as a test. Second, dilute, very dilute solution of aniline, very dilute. If you use along with CaOCl2, that is called bleaching powder, then you will get a violet color. Then you will get a violet color. But don't disturb that violet color. If you disturb, it will go. Okay, you will get a violet color, but it will go. So if there is a dilute aniline solution and you are treating it with bleaching powder, you will get a violet color, but that violet color won't stay for long. That means if you shake it, the violet color will disappear. Okay. Violet color you can see, or even purple will be, because violet just now I told about, better to write purple, not violet. Purple. So diluted aniline plus CaCl2 is purple color. If you shake it, it will go. Okay. This is the test for aniline that you need to remember. Nothing else you will remember from here. Achha. These are the use of aniline. If you want to read it, please read it, because I have nothing to explain over here. Just you have to memorize this use of aniline. Is it clear? Use of aniline you have to memorize, because I cannot help you out with this. Okay. I think you all have read it once. Let's come back to the syllabus portion once. Test for aniline discussed, usage of aniline discussed. Now we have cyanides, alkyl halides, amide, isocyanide, alkyl halide. Quickly let us complete this, because this is a very small topic. Cyanide is not a very big one. So let us completely do it. Method of preparation of cyanides and isocyanides. So first let us discuss about cyanide, then I am going to discuss about isocyanide. Cyanides from alkyl halide. How will you prepare? Reaction was done in haloalkanes and haloarenes. Generally we have discussed this reaction. So if you have Rx and if you are treating it with KCN, then you get a RCN plus KX, right? Because KCNA, the attack is from the carbon center. The attack is from the carbon center. I told you this. Carbon center. Okay. Just this much. Example, if you want, you can just make it out because it's not a very difficult task. Second, next one. Amide. Amide, if you have a RCONH2, then you either give P2O5 or you give SOCl2. Both of these will result in a cyanide. And you know that P2O5 is a very good dehydrating agent. P2O5 is a very good dehydrating agent. So immediately the H2O will go out. So carbon will get 3 hand empty. So this will form 2 more double bonds. Sorry, 2 bonds. Okay. So this one is an important reaction. Not forget this reaction. Why is it all same color? Okay. Next one. Method of preparation of IC. This is an easy topic, so I have nothing to explain about it. Method of preparation of isocyanate of alkyl halide. How will you prepare? Using AgCN. Using AgCN. You can prepare Rn triple bond C plus K, sorry, plus AgX. Okay, here the attack is from N center, not from the C center. Okay, next, primary amines. How will you prepare from primary amines? You already know the reaction. It's nothing but carbylamine reaction. Nothing but carbylamine reaction. The carbylamine is the isocyanate. So if you have Rx, sorry, if you have RNH2, which is a 1 degree amine, and you treat it with CaCl3 and alcoholic KOH, right? Then you get a isocyanide along with 3 KCl and 3 water. So you can see, so everything you know, it's easy, done. So let us check what we have done now. Method of preparation: cyanide, alkyl halide, amide, isocyanide, alkyl halide, done. Peptidamine done. The diazo is left. Diazo I will do now. Now let us go to diazo. Only we are left with this much part. Diazo. Let us come diazo. Diazo preparation. Preparation of diazonium salt. Preparation of diazonium salt discussed before. Diazotization reaction. Entire mechanism Shomet we have discussed it before. So please go and watch it. Already in this video only we have discussed. Just sometime before only we have discussed when I was teaching you amines. Okay. Done. So I will not discuss this anymore. Now we'll go for the chemical properties. Those reactions are also done in haloalkanes, haloarenes. Now we will be learning the chemical properties of diazo group. Okay, so let's start. Chemical properties of diazo group. First one is replacement by H atom. So how will you replace the N2Cl minus with an H using H3PO2? So the reaction is as follows. You have diazo. I am showing by diazo part. Okay. Okay, let's go with Cl minus. Not a very big deal. We will be using H3PO2. Okay, we'll be using H3PO2 in presence of water. That is actually aqueous solution. So what we will get is, we will get benzene, that is substitution by H will make a benzene, right? Right. And this H3PO2 will get oxidized. So this will get oxidized to what? H3PO3. Along with that, the N2 gas will be released and we will get a HCl gas also. Is it clear? So what did just happen over here? You see H3PO2 to H3PO3, this got oxidized. Alright. Alright, so this got oxidized. Another thing I missed out that I should have written over here, that is copper ion. Copper ion is a catalyst, so do not forget copper ion. I did not write it. Let me write it. Slash copper ion. Copper ion must be there. This copper must be there. It will be acting as a catalyst for this. Okay. Next reaction. So it's easy. Replacement by OH group. So how will you introduce OH group? Simply will heat and distill. So it will be N2 plus Cl minus. If you heat and distill. Okay. If you heat and distill, then what will you get? You will get phenol plus HCl plus N2. Okay, is it clear? So you have to heat and distill. So you can write heat and distill, but according to your book, it is written H2O H2SO4. So you can go by that. Not a very big problem with all. So according to your book, it is given H plus H2O heat. That is only acid heating or whatever, no problem. You write this or you write that, but your book has written this, so go for that. Okay, so if you are replacing by OH group, you will use acid, concentrated sulfuric acid, dilute sulfuric acid along with water and heat it. You will get phenol and N2 will go out. Okay, done. Next, replacement by NO2 group, nitro group. So we have benzene diazonium chloride, first we'll treat it with HbF4. HbF4, then what will happen? Then this Cl will get replaced with Bf3 minus, right? So this will happen N2 plus Bf4 minus, and here HCl moves out. Okay, now following step we will use NaNO2. Then what will happen? We'll get a nitrobenzene along with Bf3 along with N2, and HCl and Na will react to form NaCl. Okay, alright, it is understood that why is this reaction happening. Now this Na that is moving out will react with this Bf3. You know, Bf3 is an electron deficient compound. Bf3 does back bonding due to what reason? Because it is an electron deficient compound. You can calculate, you will find boron has only 6 electrons, so it is an electron deficient compound. So Na easily reacts with Bf3 to form NaBF4. So instead of Bf3 we will write NaBF4. Okay, clear? Right, let me just repeat the three reactions. Replacement by H atom, then you will use H3PO2 in presence of water and copper ion, then you will get benzene along with that H3PO3, N2 and HCl. Done. If you are trying to replace by OH group, then you will just heat in presence of acid, water. Okay, so acid, any acid you will write. Okay, usually go for concentrated H2SO4. You go for H2SO4. I'm writing over here. Okay, so if you want to replace by OH group, then N2 plus heat along with H plus water, you will get phenol HCl N2. Done. If you want to replace it by nitro group, then first you use HbF4, then the Cl minus will be replaced by Bf4 minus. Next step, use NaNO2, then NO2 will enter and sodium will react with Bf4 to form NaBF4, and N2 will move out. Clear? This is replacement by NO2 group. Next reaction, we have Sandmeyer reaction. See here, Sandmeyer reaction and all these reactions we have discussed in the chapter haloalkanes and haloarenes, already discussed. So you should have learnt it by now. What is Sandmeyer reaction? So Sandmeyer reaction is N2 plus Cl minus. You use what? Cu2 Cl2 in presence of the corresponding halogen acid. Then you will get the respective halogen acid, right? So instead of this, if I use bromine, then I will get bromine over here. Not a very big deal. So let me just use over here. So if I use over here Cu2Br2 in presence of HBr, then I will get here Br. This is Sandmeyer reaction, right? Now another reaction is there, which is very similar. It's called Gartenmann reaction. Gartenmann reaction, what we will use? We will use N2 plus Cl minus, and we will use copper slash HCl. Then also we will get the same product, but the reagent is different. Sorry, right? Another one, let me show. These are already known to you, nothing much to explain. N2Cl minus Cu slash HBr. Then also you will get Br along with N2. Okay, clear. Next reaction is Ball-Schiemann reaction. This was also discussed. What did we do for Ball-Schiemann reaction? We had N2 plus Cl minus. We reacted that with HBF4. Then we got N2 plus BF4 minus. Then this one we reacted, we heated it. So if we heat it, then what we will get? We will get F, BF3 will be released, N2 will be released. So this was the Ball-Schiemann reaction, which used to give us fluorohalurine. Right? This is Ball-Schiemann reaction. Clear? Next. Coupling with aniline. Coupling. Coupling means joining. You know what's a couple in literal sense? So same thing. Coupling means joining. So one side it will be an aniline molecule and one side will be a diazo molecule. They will be joining together. Okay. How? Let us understand. Aniline. First I am showing you. Aniline is NH2. Not on this page. This page I have to write the reaction. See here. Aniline is NH2 and diazo is NNCl. Now if I don't write the Cl this side, I'm writing the Cl this. Any problem? No. So HCl I can throw it out, one H. That will move out. That one is going to be eliminated. And the remaining products they will join. Okay. Okay. Do you understand this? Okay, did not understand. Fine. Forget it. Easily let me explain. This might be a little bit complicated. So I am making it easy. I'm making things easy for you. See. Forget. Whatever I said, forget it. Now listen to me what I'm saying. You saw that this is aniline, right? Here in the para position there is a hydrogen, right? And this is diazo. Remember this side one is plus, okay? One is plus. Now this hydrogen and this chlorine I can throw out. Can I? Right? Moment I throw out, this will come and link over here. Now if this hand is already linked to this one, it's already linked over here, then this bond has to break. Right? Nitrogen cannot form four bonds. One bond has to break. So this one bond will break from here. Okay. So moment you can see that Cl is taken up by this hydrogen. This nitrogen is plus charge. This will come and develop over here. It has to break one bond. This one will also get plus. Both are plus. So there must be one bond that has to be broken. Because three bond and both are plus, not possible for nitrogen. So bond will break and will be N double bond then, which will be actually joining these two benzene rings. Clear? This is diazo reaction. Coupling. So this slide you need not see. Let me reading this slide. So what did I say? You have benzene. This is a benzene. Okay. I am turning the benzene and let us take that this one is aniline. Okay. So what did I say? That this percent, let us turn this one also. Let us turn this one. Done. So if this is diazo, then there must be N triple bond N plus Cl minus and this is H2. This here is an H. Right. So this 2 will go out. Let me show you the different color. This person will move out. So if I have to proceed through this reaction, then what will form? This person will be there. N now will break one bond because 4 bonds N cannot have. So N has broken one bond and this has joined that side. So simply you will put the second benzene ring over here. In the exam you did not show all this. Directly you need to show the coupling reaction. So now okay. So this is the dye that has been formed. So this is the coupling reaction that is shown by aniline with diazo. Name of this is para amino azobenzene. Name of this is para amino azobenzene. This is a dye. Okay. So did you understand that coupling with aniline, how that is happen? Achha, this happens in presence of an H plus. Okay. Just mention this H plus. Temperature not required. It's given but not required. 313 to around 313 to 303 Kelvin required. Not temperature is not required because there is an intermediate step that I was telling the NH to H will go. If I go by that format, then there will be an intermediate two steps that I have not told you. I have just overgone. So that's not needed right now. Okay, so this is the reaction we are going to follow for your ISC syllabus. If you want to note down the temperature, you can note down it is 303 Kelvin to 313 Kelvin. H plus. Done. Coupling with phenol, same way, nothing is different, exactly same. Then what will be the change? Name will become para-hydroxyazobenzene, and here instead of NH it will OH. So is there any change, big change? No, just OH in place of NH. Simple. Okay, so let us just copy this entire thing out here to the next slide, because knowing this will take up time. So this person is, temperature will not be this one. Okay. So this will become OH. Right. This will become OH. This is phenol. Temperature for this reaction is 273 to 278 Kelvin. 273 to 278 Kelvin. Did you understand? So there is no change with coupling. Main thing is you will remove HCl from there and you will write. Okay, I did not write minus HCl. Huh? Please don't forget that. Like I keep forgetting. Minus HCl. Okay. So the name of this compound will be para-hydroxy azobenzene. Para-hydroxy azobenzene. Clear? So this is importance of diazonium salt, which has been mentioned in the syllabus, so I had to give it. Just give it a reading because I cannot say anything about it. See here what is written: used in dye industry to make azo dyes. You can see so many azo dyes are coming into formation with this coupling and all. Used in converting arylamines into a wide range of aromatic compounds. Obviously, from arylamine you can go to variety of compounds using diazo salts, right? Lastly, widely used preparation of haloarenes. Yes, we can prepare haloarenes from diazo and substitute halogens, etc. So these are importance of diazonium salt in our organic chemistry. Okay, so this concludes this chapter. Thoroughly give it a reading. Coupling reaction is very new to you and expected one question from coupling reaction. So read it accordingly. Okay, let me just confirm that the syllabus is done. See here, diazonium salt preparation, chemical importance of synthetic organic chemistry done. The aniline, Sandmeyer, Caterman, Valskibben, replacement diazo group by H, OH, NO2 done. Coupling with phenol aniline done. So this is done. I have written officially done. So that's all. This concludes this chapter. I hope you have enjoyed this chapter, enjoyed this lecture. Please give it a reading and all the best for your exams. Okay. So thank you for joining the lecture. Read, practice. Okay, see you all in the next lecture with alcohol phenol ether as the next topic. Thank you.